Okay, now we're going to do some stoichiometry with solutions. So we know for stoichiometry, we have to use the balanced equation and those mole ratios of reactants and products in order to figure out if I have so much of one thing, how much of the other am I going to make. Okay? So molarity is just one more way to convert to moles. So if you think about it, molarity is number of moles over number of liters over the number of liters. Okay? So moles, if I cross multiply, is molarity times liters. Okay, so let's take a look. So we have been developing a mole map along the way. We know we can go from mass to moles using molar mass. We know we can go from number of particles to moles using Avogadro's number. If we're at STP, we know we can take the gas volume and convert that to moles using 22.4 liters per mole. So all we're going to do is add another spoke here, and if we know our solution volume, we can convert that to moles using molarity. Okay? So that's all it's going to take, is knowing that I have a conversion that I can use. So I can use 1 liter over X moles or X moles over 1 liter, and that's what molarity is. So let's take a look at how we use it. Alright, so cells in the stomach release hydrochloric acid during digestion. If they release too much, the acid can be excess, and it can be neutralized with antacid. A common antacid contains magnesium hydroxide, which reacts with acid to form magnesium chloride in water, and the balanced equation is given to you. And we want to know how many milliliters of 0.13 molar HCl are required to react with an antacid tablet containing 0.85 grams magnesium hydroxide. So as you know, the first thing you always have to do when you're doing stoichiometry is to make sure you have a balanced equation. So I have 2 chlorines here, so I'm going to need 2 here, and now I need 2 waters to make a balance. Okay. So don't forget, molarity is moles of solute over liters of solution, and we're given a molarity in this problem. Now for stoich, we should always start off with the amount we're given of something. So let's start with 0.85 grams of magnesium hydroxide, and just let factor label help us figure out what comes next. So if I have 0.85 grams of magnesium hydroxide, I'm going to want grams of magnesium hydroxide on the bottom, and I'm going to convert that to moles of magnesium hydroxide. Okay, and now I need to use the mole-to-mole ratio. 1 mole of magnesium hydroxide will require 2 moles of HCl, and now I know the molarity, and I can use that in a factor. 0.13 moles of HCl is 1 liter of HCl. Now I'm looking for milliliters, so I need one more conversion to go from liters to 1,000 milliliters. I can cancel units. I'm left with milliliters, which is the units that I want. So when I punch this, I get 224.2. I want 2 sig bigs in my answer, so the answer is 220 milliliters of HCl. Okay, let's take a look at the next one. Barium chloride reacts with sodium sulfate to form solid barium sulfate and aqueous sodium chloride. Write the balanced equation. Alright, we have barium chloride. Barium is a +2, so I need 2 chlorine. It's going to react with sodium sulfate. Sodium's a +1, sulfate's a -2, so I need 2 sodium. And it's going to produce barium sulfate. Barium is a +2, sulfate's a -2. And I'm going to add to that sodium chloride, and when I do that, I'm going to end up with 2 sodium chloride in order to get the equation balanced. So the question is, how many grams of barium sulfate form when 35 milliliters of 0.16 molar barium chloride react with excess sodium sulfate? So I'm going to start with the amount of the given that I have, 35 milliliters of barium chloride. And in order to be able to use the molarity as a factor, I've got to convert milliliters to liters. And then I use my molarity, right? 1 liter is 0.16 molar barium chloride. And I have a redundant factor there. I'm just going to cross that out. And 1 mole of barium chloride will give me 1 mole of barium sulfate. That's the mole ratio in the balanced equation. And I'm looking for grams of barium sulfate, so 1 mole of barium sulfate is going to be 233.4 grams of barium sulfate. And when I multiply, first cancel units and multiply it out, I get 1.307 grams. I want 3 sig figs based on my givens, and when I do that, I get 1.31 grams of barium sulfate. Alright, and that's going to do it for us.